Hi everybody, this is Mr. Raed Al-Nusayrat. In this video, we will talk about lesson 3.8 from grade 12 Advanced, term 1. Lesson name is Implicit Differentiation and Inverse Trigonometric Functions. We have some learning objectives today. Find derivatives implicitly. Use implicit differentiation to find derivatives of inverse trigonometric functions. Solve mathematical and real-life problems using implicit differentiation. And in this video, we will focus on the learning objective number 3. So we'll talk about some applications. We have some keywords: implicit differentiation, inverse trigonometric functions, horizontal tangent, vertical tangent, and orthogonal curves. The first application we have in this lesson is rate of change of volume with respect to pressure. Under certain conditions, van der Waals equation relating the pressure P. So in this equation, we have pressure P and volume V of a gas S. The equation is P plus 5 over V squared times V minus 0.03 equal 9.7. Use implicit differentiation to find the derivative dV by dP at the point 5 and 1. So 5 is the value of P, because it's take the place of x, and the 1 is the value of v, which is the value of y. Okay, I will start from my equation. So p plus 5 over v squared times v minus 0.03 equal 9.7. To find the derivative dV by dP, I will use the implicit differentiation. But here I have a product between two functions, so I will use the product rule. So the derivative for the first one, P plus 5 over V squared, derivative of P, it's 1, plus derivative of 5 over V squared, it's negative 5, times derivative of denominator, which is 2v v prime as implicit differentiation, over square of denominator, which is v to the power 4. So this is the derivative for the first term, times v minus 0.03 plus the first term is the same, p plus 5 over v squared, times the derivative of the second term, which is derivative of v, which is v prime, equal derivative of 9.7, it's 0. Now I will make some simplifying here. So the first bracket is 1 minus 10 v prime over v cube, because minus 5 times 2, it's minus 10. V cancel with 1 of the v's in the denominator, so v over v to the power 4, it's v to the power 3 in denominator, times v minus 0.03 plus p plus 5 over v squared times v prime equals 0. Now I will substitute the value of p and v, which is 5 and 1 here in this equation. So 1 minus 10 v prime over 1 minus 0.03 plus 5 plus 5 over 1, because 1 squared is 1, v prime equals 0. So here 1 minus 10 v prime, 1 minus 0.03, it's 0.97, plus 10 v prime equal 0. 0.97, I will make multiplication with the bracket here. So it's 0.97 minus 0.97 times 10 will be 9.7 V prime plus 10 V prime equal 0. Now, minus 9.7 V prime plus 10 V prime will give me 0.3 V prime equal, when I take this to another side, will be negative 0.97. So here V prime equal minus 0.97 over 0.3. Let me check again the product here. I will change the color. So minus 0.97 times 1, it's 0.97. 0.97 times 10 V prime will be 9.7 V prime plus V prime. Now 10 minus 9.7, 10 minus 9.7, it's 0.3. So here V prime equal minus 97 over 30, because here it's 30. This is the value of V prime, which is dV by dt. So dV by dP, equal minus 97 over 30. Now we will go to another example, modeling the rate of change of a ball player's gaze. One of the guiding principles of most sports is to keep your eye on the ball. In baseball, a batter stands 2 feet from home plate. So the batter stands 2 feet from the home plate. This is the home plate here in the picture, and this is the batter. So the distance from the batter and the home plate is 2 feet. As a pitch is thrown with a velocity of 130 foot per second, about 90 miles per hour. So the velocity for this ball is 130 foot per second. Okay, assuming that the ball only moves horizontally, so the ball is moving horizontally. At what rate, he asked me about the rate, does the batter's angle of gaze need to change? So he asked here about the rate, about the angle. Which angle he talked about? If I look here to the overhead view for this problem, this is the angle which I talk about. This is the angle theta. He asked me about d theta by dt, or I can write it as theta prime of t. What is the value of d theta by dt? Need to change to follow the ball as it crosses home plate. So he asked about d theta by dt at the moment which the ball crosses the home plate. Now, if I put the distance between the ball and the home plate, it's d. So he asked me about d theta by dt when d equals 0, because at the moment which the ball crosses the home plate, this distance will be 0. Now, I have a question here. What about this distance d? It's increasing or decreasing? This distance will be decreasing because by the time the value of d will be decreased. So this number, 130 foot per second, this is represent about d prime of t, the derivative of t, which is the velocity of the pole, which is negative 130 foot per second. Why I put negative here? Because the value of d is decreasing, so the velocity will be a negative. Also, we can talk about directions. This player, when he kicks the ball, the direction is in this way. So this is the positive direction. The ball, when coming in this direction, will be negative direction. So for that, the velocity will be a negative. Now, a question now, how can I find the derivative of theta at this moment? I must find an equation between theta, 2, and d. Don't forget that this triangle is a right triangle. So I can say tan theta equal d over 2, because the tangent of theta is the opposite over adjacent. So the opposite is d and the adjacent is 2. Now from this, I look for theta. So I can say theta equal tan inverse d over 2. After that, I will find the derivative. What about the derivative of theta? Derivative of theta is theta prime of t. What about the derivative for tan inverse? As I know before, the derivative of tan inverse is 1 over 1 plus x squared. So the value of x is d over 2. So d over 2 squared times derivative of d over 2, which is half d prime of t. Now, theta prime of t, derivative of theta at time t, equal 1 over 1 plus 0. Why 0? Because the value of d, it's 0. So 0 over 2 is 0, 0 square is 0. So here 1 plus 0 times half d prime of t. D prime of t is negative 130. From this now, I can find the final result. So the final result is minus 65. What about the unit here? Because I talk about theta, derivative of theta, this will be radian per second. It's radian per second, while d in foot per second. So the derivative of theta, theta prime of t, is in radian per second. Some students ask, can I use 90 meter per hour here? Here, no, you cannot use it. You must change it to the unit foot per second. So if you want to find the derivative of theta in the unit radian per second, you must use the velocity as foot per second. This is mil per hour, sorry, 90 mil per hour. Okay. This is a question we will talk about the horizontal and vertical tangents. Find the locations of all horizontal and vertical tangents of x squared plus y squared minus 3y equal 0. To talk about horizontal and vertical tangent, first of all, I must find the derivative from implicit differentiation. So the derivative here is 2x plus derivative of y squared is 2y prime. Derivative of 3y, it's a 3y prime, and derivative of 0 is 0. From this, I must find y prime. So 2y prime minus 3y prime equal negative 2x, and I take the other side. So here take y prime as a common factor, so 2y minus 3 inside the brackets equal minus 2x. So here I can say y prime equal minus 2x over 2y minus 3. This is the derivative of y. Now, when I talk about the horizontal tangent, in this case, slope must be equal 0. After that, the derivative must be equal 0. So when this derivative equals 0, this derivative equals 0 when the numerator equals 0, only numerator equals 0. So minus 2x equals 0. So from here, I can find the value of x, which is 0. If you find the value of x, you can, from the equation, x squared plus y squared minus 3y equals 0, you can find the value of y. So here I will put 0, so 0 squared plus y squared minus 3y equals 0. That means y squared minus 3y equals 0. If I solve this equation, I can take y common factor, so y minus 3 equals 0. So I can find the value of y, which is 0 and 3. So I have horizontal tangent at 2 points. The first point is 0 and 0. And the second point is 0 and 3. So the horizontal tangent for this curve will come 2 times at the point 0, 0 and the point 0, 3. The second part from this question, what about the vertical tangent? Vertical tangent. Vertical tangent, it's coming when the slope or slope undefined. Slope is undefined when the denominator equals 0. So 2y minus 3 equals 0. From this, I can find the value of y, which is 3 over 2. After you find the value of y, you can back again to the equation. So x squared plus 3 over y squared minus 3 times 3 over 2 equals 0. So x squared plus 3 over 2 squared, it's 9 over 4, minus 3 times 3 over 2, it's 9 over 2 equals 0. So x squared, 9 over 4 minus 9 over 2, it's minus 9 over 4. From this, I can find x squared equal 9 over 4. If I take the radical for 2 parts, 2 sides, sorry, x equal plus minus 3 over 2. So here I have 2 points. The tangent is vertical. The first one is 3 over 2 with a 3 over 2. And the second one is x negative 3 over 2 with y 3 over 2. In this example, he asked me about show that the families of curves y equals c over x and y squared equal x squared plus k are orthogonal. Now, what's the meaning of orthogonal curves? Orthogonal means that the tangent lines to the curves at the intersection points. What's the meaning of intersection points? Intersection points means that intersection points mean that two curves are equal. They have the same value. They intersect each other at the same point. Are perpendicular. So the tangent at the intersection points perpendicular, that means these families of curves are orthogonal. So if I start from here, first of all, I must find the derivative for the first function and the derivative for the second function. So the first function y1 equals c over x. The derivative is y1 prime equal negative c over x squared. The second function y2 squared equal x squared plus k. I will use here implicit differentiation. So 2y2 prime equal to x, because the derivative of k is 0 because k is constant. From this, I can say y2 prime equal 2x over 2y2, which is equal x over y2. Now, the slope of the first function is y1 prime, and the slope of the second function is y2 prime. So here I will take y1 prime times y2 prime. If I can prove that y1 prime times y2 prime equal negative 1 when y1 equal y2, because we talk here about intersection points, so the value of y must be equal. Okay, if I can prove that this value equal negative 1, that means they have perpendicular tangent line at the intersection point, so they are orthogonal. I will start now. y1 prime is negative c over x squared times y2 prime is x over y2 squared. So this is negative c over x times 1 over y2 squared, because I cancel x with x from the denominator. Now, c over x, as I know before, c over x, it's the first, c over x, it's the first term. So this is y1. So here I have negative y1 times 1 over y2. I have a mistake here, so I will erase it. Here I don't have a square. I'm very sorry about that. Because if I look here, y2 prime, it's x over y2, just y2. So here, y2 prime, it's x over y2. Good. Now here, don't forget, y1 equal y2. So I can cancel this with this. So the final result is negative 1. Because the first slope times the second slope, they are equal minus 1 at the intersection point. So y1 and y2 are orthogonal. Two curves are orthogonal. Now we have more recap for this lesson. Don't forget our derivative rules in this lesson. D by dx for gy as a chain rule, it's g prime of y times y prime of x. Derivative of sine inverse 1 over radical 1 minus x squared with x between minus 1 and 1. Cosine inverse negative 1 over 1 radical 1 minus x squared, also x between negative 1 and 1. Tan inverse, the derivative is 1 over 1 plus x squared, and the derivative of cot inverse is minus 1 over 1 plus x squared. Derivative of secant inverse is 1 over absolute x times radical x squared minus 1 with absolute x greater than 1. Also, a derivative of cosecant inverse is minus 1 over absolute x times radical x squared minus 1 with absolute x greater than 1. Thank you very much, and see you again, inshallah.